The Earth's rotation around the Sun is a fascinating and complex process that drives much of the behavior we observe on our planet, including the seasons, climate patterns, and the cycle of day and night. This motion is governed by fundamental principles of physics and astronomy, and understanding it requires knowledge of orbital mechanics, gravity, and the dynamics of our solar system. To describe the Earth's orbit around the Sun in detail, we must explore several key aspects: the nature of the orbit itself, the forces involved, how the Earth's axial tilt and elliptical orbit affect the seasons, and the time it takes for one complete revolution. The Earth's orbit around the Sun. The Earth's orbit around the Sun is elliptical, meaning that it follows a slightly oval-shaped path rather than a perfect circle. However, this ellipse is very close to being circular, with the Sun located at one of the two foci of the ellipse. The shape and characteristics of this orbit are the result of gravitational interactions between the Earth and the Sun, as well as the Earth's motion through space. The Earth's orbit has a semi-major axis, the average distance between the Earth and the Sun, of about 93 million miles, 150 million kilometers, a distance that is referred to as an astronomical unit, AU. This distance is not constant, as the Earth's orbit is slightly elliptical. The closest point to the Sun, called perihelion, occurs around early January, and the farthest point, called aphelion, occurs around early July. At perihelion, Earth is about 91.4 million miles, 147 million kilometers from the Sun, and at aphelion it is about 94.5 million miles, 152 million kilometers away. Despite this variation in distance, the length of the Earth's orbit remains nearly constant each year. The time it takes the Earth to complete one full revolution around the Sun is known as a year, or more precisely, a solar year, which lasts approximately 365.25 days. This period is responsible for the cycle of seasons that we experience. 2. The Earth's axis and tilt. One of the most important factors influencing the Earth's relationship with the Sun is the tilt of the Earth's rotational axis. The Earth's axis is tilted at an angle of about 23.5 degrees relative to the plane of its orbit around the Sun. This tilt is crucial in creating the seasons and leads to variations in the intensity and duration of sunlight received at different latitudes during the year. Because of this axial tilt, different parts of the Earth receive varying amounts of sunlight as the Earth orbits the Sun. When the North Pole is tilted toward the Sun, the Northern Hemisphere experiences summer, while the Southern Hemisphere experiences winter. 6 months later, when the South Pole is tilted toward the Sun, the Southern Hemisphere experiences summer and the Northern Hemisphere experiences winter. This axial tilt also causes the length of the day to vary depending on the time of year. Around the equinoxes, which occur in late March and late September, the Earth's axis is neither tilted toward nor away from the Sun, resulting in nearly equal day and night lengths across the planet. These points mark the transition between the seasons. 3. The role of gravity in the force that governs the Earth's motion around the Sun. Isaac Newton's law of universal gravitation explains that every object with mass attracts every other object with mass. The Sun, being much more massive than the Earth, exerts a gravitational pull on the Earth, causing it to move in an elliptical orbit around the Sun. At the same time, the Earth exerts a gravitational pull on the Sun, but this force is much weaker due to the Earth's smaller mass. The balance between the gravitational pull of the Sun and the Earth's forward motion through space is what keeps the Earth in orbit. If the Earth were to stop moving forward, it would be pulled into the Sun due to gravity. Conversely, if the Earth were to move too fast, it would escape the Sun's gravitational pull. The Earth's current speed of about 29.8 kilometers per second, 107,000 kilometers per hour, or 67,000 miles per hour, is just right to keep it in orbit, neither falling into the Sun nor flying off into space. 4. Orbital speed and velocity. The Earth's orbital speed is not constant, as the shape of its elliptical orbit means that the Earth moves faster when it is closer to the Sun at perihelion and slower when it is farther away at aphelion. This is due to a principle known as Kepler's second law, or the law of equal areas, which states that a line segment joining a planet and the Sun sweeps out equal areas during equal intervals of time. As a result, When the Earth is closer to the Sun, it moves faster, and when it is farther away, it moves slower, ensuring that the area swept by the line connecting the Earth and the Sun remains constant. 5. Seasons and their connection to Earth's orbit. The tilt of the Earth's axis relative to its orbit around the Sun is responsible for the changing seasons. As the Earth moves along its orbital path, the angle at which sunlight strikes different parts of the Earth changes, leading to seasonal variations. During the course of a year, different regions of the Earth receive more or less sunlight, depending on their position relative to the Sun. In the Northern Hemisphere, the summer solstice occurs around June 21st, when the North Pole is tilted most directly toward the Sun, resulting in the longest day of the year. Conversely, the winter solstice, occurring around December 21st, happens when the North Pole is tilted away from the Sun, leading to the shortest day of the year. The opposite is true for the Southern Hemisphere, where the solstices occur 6 months later. The Earth's rotation around the Sun is a fascinating and complex process that drives much of the on our planet, including the seasons, climate patterns, and the cycle of day and night. So friends, I am ending the video here. Thanks for watching. Subscribe now for more episodes.